Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my wonderful students of Senior 1. I want to welcome you so much for another session of 30 minutes of TV learning, and I hope you are going to enjoy our sessions together. Now, as always, I want to begin by introducing myself, and if you come with me to the board here, my name is Teacher JB, your physics teacher, as always, and today we are going to start a new unit, okay? A new unit which is Unit 5. We already finished Unit 4, which was about Newton's laws of motion, and so today we are going to start a new unit, which is Unit 5. And what does Unit 5 talk about? Unit 5 talks about the center of gravity, okay? Center of gravity. I believe it is a new word to you, but we are going to learn more about center of gravity. So our lesson today is about the center of gravity of irregular lamina and regular lamina. Those are new words, right? But we are going to learn what those things mean in this lesson. And so the key unit competence for this Unit 5 is going to be, you should be able to determine the position of center of gravity of a body. That is what the unit is all about. We should be able to determine the position of center of gravity of a body. If again you remember, our lesson title today is Center of Gravity of Regular and Irregular Lamina. Okay, let's move ahead. And as I will be explaining, we shall have all this on the board, like the unit title, lesson, and unit competency. Everything will be on the board so you can check it up. Okay, let's look at learning objectives for today. Our learning objectives for today, we have three, basically. One, you should be able to define center of mass and center of gravity. We should be able to do that. Two, we should be able to determine the center of gravity of a regular lamina. Then three, we should be experimentally able to determine the center of gravity of an irregular lamina. We want to succeed in doing all those three. And I hope you are going to enjoy the lesson. Okay, let's move ahead. The key words that you are going to encounter during this lesson are, you have equilibrium, okay? You have particles, atoms, and molecules. Those are new words. You have mass, you have gravity, you have center of gravity, you have regular and irregular lamina and center of mass. So those are the new words that we should be able to look at, today. Now, as we move through the lesson, we shall discover what those words are. But even if we don't, you can go to the internet and then, or your textbook, remember our reference is on the board as well. You can go to the internet and search for some of those words. Okay, let's move ahead. Right. So let's begin by looking at what we call center of gravity. Center of gravity. Now, to enable us understand the meaning of center of gravity and equilibrium, I will want you to come here with me. I have a set of apparatus that we have arranged together. As you can see, we have two candles there that have been, held in equilibrium. And when I talk of equilibrium, I mean the candles are not moving. If you look at the candles very well, they don't appear to be moving. So we say they are in equilibrium. So what I'm going to do, I'm going to set the candle on fire. I'm going to begin burning them. And throughout this lesson, we will observe what will happen to the candle. Remember, we are starting with the candle in equilibrium. Okay? We are starting with the candles in equilibrium. So let's just set the candle burning. Okay? That should catch fire. I'm also going to set the other one burning. We will come back to this experiment as we move through the lesson. But remember, we have started when the candle is in equilibrium. Let me also set the other one on fire. Okay, I'll blow this one off. We'll come back to that. We'll observe what will happen to the candles. And I believe this will help us to understand and define center of gravity. But for now, let's move ahead. Center of gravity is a point on a body where the total weight of the body appears to be concentrated. That's what we call center of gravity. It is a point on a body where the total weight of the body appears to be concentrated. Now, when you look at our diagram here, okay, there are so many atoms or molecules that make up that matter, that make up that lamina. And there are very many. But we cannot draw all of them. So here we have drawn just a few, okay? We have drawn a few, and each of them has a weight. In the previous lesson, we looked at what weight means. A product of mass and acceleration due to gravity. So each of these has a weight, and a weight is a force. Now, the combination of all these weights, okay, has a resultant. And the resultant is that single force which represents all the forces being exerted by the by the gravity, by the Earth on each of these molecules. And so the resultant force will act at a point like this. This resultant force is referred to as the what? The weight. If you join me here also on the board, okay, right here on the board, you have got a lamina. A lamina is any object, like it could be a cardboard. A cardboard like this is a lamina. So these are the individual particles. As you can see, each one has got a what? A weight. But the total weight, the resultant weight, will appear to be acting from a certain point. And that point there is what is referred to as the center of gravity. So that is what we mean by center of gravity. It is a point on a body where the total weight of the body appears to be concentrated. Now, center of weight is also, center of gravity is also related to center of mass. Remember, center of gravity talks about weight. Okay? Center of mass, without mass, we cannot get weight. So, center of mass is a point on a body where the whole mass of the body appears to be what? To be concentrated. Okay, I hope you are following that. Let's come back to our experiment. You remember the experiment we started in the beginning? Try to think about it. What happened? We started when the candle was at equilibrium. Do you look at the candle? It wasn't moving. It was in equilibrium. Now, look at what is happening to the candle. Do you think I pushed the candle to make it rotate? Oh, no, I didn't do that. The candle is actually, oscillating on its own. And can we be able to use the knowledge of center of gravity to explain why the candle is rotating like that? I hope we shall be able to. Even this, you can see it is still in equilibrium. We'll continue with our lesson. We shall come back and see what will happen to this candle. Then we shall explain what is happening here in terms of center of gravity. Isn't that magical? I believe so. All right. Let's go ahead. Center of mass. Remember, we have already defined it. So we said center of mass is the point on a body, you see, where the whole mass of the body appears to be concentrated. That's what we call center of mass. Now, for a uniform gravitational field, if you go to a place where the gravitational field strength is uniform, the center of mass is going to be at the same point as the center of what? Of gravity. So in a uniform field, those two are the same, center of mass and center of gravity. Okay? Hope you're following that. Now, if you come back to one of the learning objectives here, is we want to be able to determine the center of gravity of regular lamina. Now, a regular lamina is a regular body, okay? A body with a regular shape. You must have looked at that before. So, examples that we can have, even in real life, you have objects which are in the form of a square. You see, this is a square, in the form of a square. How do we determine the center of gravity? So you draw a diagonal here and there. You see where these two diagonals meet? That is center of gravity. In a uniform field, that is also center of mass. Assume it is uniform. The thickness is the same, everything is the same. So that becomes uniform. Okay. For a circular disk like this one, the center of center of gravity is where the two diameters meet. For a triangular object, lamina like this, I think we have a copy also on the board. If you join me here, for a triangular lamina like this, what we'd do is we bisect this angle. In mathematics, we should learn how to bisect angles, okay? So we bisect this angle. We also bisect this angle. We also bisect the other angle. If you do it very accurately, they will all meet at the same what? At the same point. And that point where they meet is going to be center of gravity. Again, if you look at an object like this is a sphere, okay? Something spherical. Like this is a sphere, okay? So, if you divide this into half, you also divide that, you are going to find that, this is like a plane of symmetry. You learn about plane of symmetry as well. And this, it can divide into two. And so if you get a diameter here, and that diameter, do you see where they meet? Right inside there. It's not on the surface, but right inside there. That becomes the center of gravity. And in real life, we have so many objects that are like that. You see, like this orange, the center of gravity would be right inside there. Okay? I hope you are following on that. Then you have got other objects like, a cuboid, like this. The center of gravity is also right inside. And there are so many others. When I talk of a cuboid or a cube, I mean this. So if you join this corner, this vertex to the opposite vertex, and this to the opposite vertex, they will meet right inside. And that would be the center of gravity. And so for you, I would love you to look at so many other objects in real life and try to see where the center of gravity could be. There are other objects where the center of gravity is external, is outside the body. You look at this ring, okay? Like here, we can take an example of this. You see? The center of gravity cannot be inside the body. The center of gravity is going to be somewhere here, inside. Okay? That's what we're talking about here. If you have a stool, okay, a stool, the center of gravity is going to be somewhere under. You have got this lamina. The center of gravity is outside. You have got someone seated on a chair. The center of gravity may not be on his body. Here, the center of gravity is outside. So that is basically how we can determine center of gravity of regular lamina. Okay, my second candle is taking a bit of time, but you can see it's already beginning to move. Sorry, I wanted to remove this. Let me make it stop. Okay, let it stop. Okay, it will move. Let us look at this. Why the candle is, oscillating like this is because as you burn, you see I'm burning from both ends. When this end burns, because we started from equilibrium, when this end burns, it means the weight on the other side is going to become less. And when the weight is less, this side then goes down, because the center of gravity will be inclined on this side. And so the candle, rotates this side. As it rotates this side, the flame will be burning the candle more. And when the flame burns the candle more, what will happen? The weight on this side will also reduce. And when the weight on this side reduces, it means the other side becomes heavier. So the candle rotates on the other side. And the sequence continues. And the resultant effect is that the candle then begins to oscillate, clockwise and anti-clockwise, clockwise and anti-clockwise. As you can see, what is happening with this candle. See? Magic of center of gravity. Okay? Good. So let us continue. So we have seen how to determine center of gravity of regular objects. And so now we want to look at an experiment to determine the center of gravity of an irregular object. Okay? That's what we want to look at. Experiment to determine the center of gravity of an irregular object. So this is our irregular object, which you can see there. Okay? This is our irregular object, which you can see. And so we are going to use this irregular object, irregular lamina, to determine, its center experimentally, like it says in our objective. Okay? But I'm not going to use that shape. I'm going to use another shape. The shape I'm going to use is what we have here on the board. I just cut this cardboard. Even you can do it. Okay. I want to just see that it resembles what we have done. You see? This is what I have cut. Does it look like this? Maybe like the shape of my head, right? Not yours, mine. Okay. So this is the lamina whose center of gravity we want to discover. I have written irregular lamina, but I am going to work on this side because I need to draw some lines. So let us look at the procedures. Let's look at the procedures. First procedure, they are saying make 3 holes, okay? Make 3 holes, A, B, and C. Now what I have done, I've already made the 3 holes, okay? Just focus on this lamina, you will be able to see the 3 holes. Do you see the 3 holes? There's one here, there's one there, and this one. I'm not going to use this. I'm just going to use 3 holes. So I'm going to label those holes, A, B, and C. And so let me label this hole A, and let me label, okay, no problem. Let me label this one A, let me label this B, and let me label this C. Okay? Those are my holes. You can label it in any way you want. It really doesn't matter. Okay, let's go ahead. Suspend the regular lamina on hole A and allow it to swing freely. Okay? So we are going to suspend and allow it to swing freely. Again, you are going to join me here to suspend. So suspending, I'm going to suspend it here. I push the hole on the pin. You see, this is the pin. In our diagram, we are talking about a nail. Then the retort stand and the clamp, everything is right here. So I'm going to suspend it and allow it to swing freely. Let me put the other side where we have put A, B, and C. So you see that it's swinging, okay? So let it swing until it comes to rest. And so in the interest of time, I am going to help it to come to rest, okay? Right. Remember, I can't force it to rest here, can I? I can't. So let me just force it to come to rest so that we can save some time. Then we have a plumb line. A plumb line has a pendulum bob, a metal sphere. You can even use anything which is heavy. Then connect it to a string. So I'm going to connect it right there, okay? Like this. So put it there. Then remember, it is swinging, so we allow it to swing until it comes to rest. So when it comes to rest, let's look at the other procedure that is being told to us. When it comes to rest, we are supposed to mark a point on the lamina along the string on the plumb line when it stops, okay? And we shall join that point to A. So let's go and mark that point. Let's go and mark that point. So a point on the string. Any point along this string. Any point. So let me mark that point here. You see where the mark is? So let me make it more visible. It is here. So that is done. Let's move ahead. Coming back here, Remember, they're telling us to join that point to A. We shall do that at the end. This procedure, repeat the above procedures by suspending the lamina at B and C. So we are going to repeat the procedures by suspending the lamina at B and C. So let me remove it from here and suspend it at B and C. Okay? So let's suspend at B. Okay? Is it swinging freely? Yes. It is swinging freely until it comes to rest. I'm also going to put the plumb line in there. That is our plumb line. Okay? Let the plumb line swing until it also comes to rest. In the interest of time, I'm going to try to make it come to rest more quickly. So there it is at rest. And so we are going to mark a point on the plumb line, okay, using my marker somewhere there. Okay, let me make that point visible. Remember, this one we are joining to A, this one we are joining to B. So we complete with the point C. So I remove the plumb line again, then I suspend it at point C. Point C is right there. Then put again your plumb line. Okay, good. There, put your plumb line. Remember, this should be able to swing. Even the plumb line should be able to swing. And so, in the interest of time again, I'm going to just try to make it come to a rest quite quickly. Okay, again, I'm going to mark a point along the string. So, the point is somewhere here. Okay, then let me make it more visible. That is C. Our experiment is done in that aspect. So, I'm going to put this one there. So what are we supposed to do now? Remember what they said. We are supposed to join the points. Okay? Very quickly, joining the points. Allow me to use this space. A is right there. I'm going to join it to A. So A is there. Join it to A. Okay? Let's see what we get. So if I join accurately, that is what I'm going to have. When you're carrying out your experiment, you need to use a sharpened pencil. Me, I'm using a marker because I want you to be able to see. Let's go to the next point. B goes with the other one. Okay? B goes with that point. And remember, you should do it very accurately. Then we go to C. You join C with the other point. So if you join C with that point, let us see what will happen. Whether there is a magic that will happen. Join C to point C. Wow. Do you now see the magic there? Are they meeting at one point? Yes, they are meeting at one point. Let me get a pen of another color so you can see. Where they are meeting is right here. And this point here where they are meeting becomes the center of what? Of gravity. Isn't that wonderful? I never forged out anything. I did it nicely. You can do this. And you will also determine the center of gravity. Okay? Great. So, when you go back to your school, try doing this experiment. Very easy, and you can succeed in doing it. Okay, so let's continue. We are done with that. Again, if you come to our learning objectives, have we been able to determine center of gravity of a regular lamina? Yes. Have we been able to experimentally determine the center of gravity of an irregular lamina? Yes, we have done that. And that's why we have this. Okay, let's move ahead. Where the three lines meet is the center of gravity. That one we have talked about it. No problem. Okay. So, I will then give you an assignment. And the assignment I'm going to give you, which you will have time, I will give you time to take, will be just a few questions, very nice questions. One of them is, define the term weight of a body. B, outline any three differences between mass and weight. You have others. Differentiate between center of mass of a body and center of gravity. Talk about them. Then another one will be, describe how you would experimentally Determine the center of gravity of a non-uniform lamina using a plumb line, remember there, a pin or a nail, and a retort stand. That is the end of your assignment. I will give you time to take notes on that. So in summary, as we end our lesson today, in summary, remember, every one of you must have taken these learning objectives into account. Determining center of gravity and of a regular and irregular lamina. I hope we have been able to do that. We have also been able to define center of gravity of a body. It is right here, center of gravity, okay? We have been able to do that. We have also been able to look at equilibrium. When we say a substance is in equilibrium, like you remember we had some candles here. Unfortunately, they have burnt out and they are finished. But you remember that experiment also. And you are also able to explain why such a candle spins when it is burning on both sides, because of ideas of center of gravity. So, my wonderful students, I want to thank you so much. As I told you, try to make physics easy. So do lots of experiments and use physics to explain phenomena, things that you can experience in your daily life. I want to thank you again for being good students and being attentive. I know you have been taking notes. Continue watching other TV programs so you can increase in knowledge. Stay very safe until we meet next time. We now focus on the assignment, and then you can take your assignment. Thank you very much.